So yeah, in terms of just one more thing about the final projects, the you know, I'll definitely be prioritizing grading those. I know that for some of the assignments, I'm also working on getting getting assignment 3 to completed and assignment 2 for a few people who I haven't had a chance to grade yet. But I'll be prioritizing the feedback for the final project since it is worth such a large percentage of your grades. So, once those are submitted, expect those to be coming out sort of early in the week and early next week rather. And and then for module 6, that homework will pretty much be in service of your final project. So for most people, I'll specifically, give some points of improvement for the proposal. As I was mentioning before, this may be things like, sort of making sure that your data sets are going to be, are actually going to work in the way that you're thinking of them. So usually, I'll kind of gear module 6 towards being in service of your final project. So um, with that, I'm just going to share my screen here. Just bear with me for 1 second. There we are. Okay, so let me just share my screen. All right, so unfortunately, I was just this afternoon, I was running into issues with RStudio, getting a weird, just try one last time if it magically fixes itself. Oh, yes, that is awesome. Okay, I had to reinstall R so many times and now it's working. I was all ready to try to do this from the terminal, and I'm glad I'm able to just do this here. All right. And then let me just get to module 3. Yeah, did anyone ever receive an error in RStudio where the whole screen just shows essentially a 404 error?
No, never saw that.
Yeah, it was a weird one, but looks like that that reinstall of R ended up working. So let's talk about the app that the questions, and then the app that I have. So I'll spend some time going through homework 3, but I do want to spend most of the time focusing on Dash and then sort of going through really what I'm looking for in terms of using the Socrata API and just some concepts there. So for module 3, we were looking at mortality data across all 50 states and DC. And we have 2 questions that we're looking to answer here. So for the first question, we're looking at a particular year, and we want to be able to compare the accrued mortality rate across all states and then be able to pick which cause that we're looking at. And in particular, we would want to be able to rank states by accrued mortality. And then for the second, well, actually, yeah, I'll just sort of show that first question, and then we'll delve into what the second question is looking at. And before I do, let's just let me stop this. Let me get just look at our data here. So we're looking at the crude rate across. In this case, we're only filtering for 2010. So you could see, this data is multidimensional. It's divided by state, by ICD chapter, meaning the actual disease, and then by years, so it's a time series. And then we have our metrics looking at deaths, the population, and the crude rate. So for the first question, we're filtering by year. So we're only looking at a year in time, and we're essentially looking to compare by our by state. So getting back to the app. So I have both of my apps in the same app here, just separated by tabs. So in the first tab, we're looking at a specific year. So for our first output here, we're filtering by year. And then I have two things that we're filtering by here. We're not filtering by state yet. We're only filtering by the ICD chapter. And what I chose to do here, so I was choosing to use Plotly for Shiny, and I was choosing to really kind of see how extreme we could get with maximizing our data tink ratio. So in particular, because you have 51 regions that we're working with the 50 states and DC, it could sometimes labeling states could sometimes become an issue. Like in the first assignment, I had everyone sort of solve this problem by sort of dealing with a more vertical alignment and arranging their graph that way. But when we're sort of looking at just a Shiny app like this, what I chose was to essentially just keep the information hidden and have some sort of interaction be required in order to expose the particular states. So in this case, it's we're kind of using Plotly's interactivity in the service of maximizing our data tink ratio, and really kind of letting a user explore the states as they interact with the graph. And then further the visualization type, we're just sort of looking at a dot plot to sort of get an idea of what's happening state by state. And then just to see how we're working this out in the code, we have our UI here. So I have my two inputs, and then so we'll be watching out for ICD for the first question, and then we're filtering by that using using this here. So we have our we have our reactive function here. So that's where we're filtering by our input. Reactive functions, again, similar to what I was mentioning a few weeks ago, are not necessary in terms of performance. This is a pretty light data set, so this is mainly just to kind of show off this style in making Shiny apps. And as we move into Dash, you'll see that this style is sort of more readily apparent there. So, we're using this selected data to filter by ICD chapter. And then for the first question, just looking at our output here, we're using that selected data, further filtering it by 2010, and displaying the results using Plotly. So it's pretty straightforward. It's just a scatter. This is just simply a scatter plot where we're making sure that we have a marker mode. And then for the second question, we're sort of now looking at the time dimension of this. So we want to, try to get an idea of whether states are improving their mortality rates per cause, and in particular comparing this to the national average. So this involves a few things. So first of all, this national average is something that we would need to calculate from the data. But basically, what we want to do with this question is to sort of see this, sort of visualize this comparison with the national average. So going back here, first we'll just show off now when we're looking at the states, we're able, the states are meaningful now because we're not comparing all of them at once. So we could take a look at different states and different diseases. So if we go to some like West Virginia for endocrine diseases, seem to be a pretty big outlier. But if we look at how the rate is changing over time, there are some more drastic swings, but it's somewhat comparable to it's not sort of predictably over or under the U.S. average. It's just sort of more volatile, it seems. And then for the second question, really the meat of what I'm doing is calculating this national average. So you could see, sort of the dplyr steps that I'm taking here. So I'm using this weighted mean, looking at the crude rate compared with the population, and then adding that to my data frame, and sort of getting a getting a national average data frame, then getting a state data frame, and in this case I was just R-binding both of them and feeding that into Plotly. So any questions on sort of what methods I chose here? So basically pretty simple inputs I was using, just using kind of the canned elements here. So my sidebar panel and my main panel. Shiny is really good with sort of dealing with tabs, like they're just panels in the same way that these other UI elements work. So I sort of have I was able to pretty easily add a tabbed view. Although if anyone just created two separate apps, that's totally fine. And then lastly, sort of how everything is working in the server. Any questions overall? Cool. So with that, we'll move on to assignment 4. So for assignment 4, this one is a bit more complex in a few ways than assignment 3. So you'll notice that I kind of returned to the some of the earlier assignments where part of the assignment here is really, kind of choosing what sort of visualization you're using. So there is a degree of, there's more of a degree. It's like less prescriptive in that way, and but it's also using a new tool, Dash, and in particular, I have everyone using the Socrata API. And I did that for a particular reason because, um, first I wanted to kind of give everyone some exposure to what working with these APIs are like. Socrata, by the way, is a great source for final project data if you're still looking for inspiration. There's a lot of city open data sets, and those are great sources. But Socrata is I wanted to. And where am I? Oh, I'm in the wrong folder here. Oh, I know where I needed to be. Sorry about that. This was what I provided you guys, so I could just be here. All right. So let's start talking about what the data set is. So we're looking at the tree census for New York City. So this is a really cool data set. This was actually something that was put together by the city. There were tons of volunteers who took part in terms of logging trees either on their own property if there are trees in their backyard, or sort of gathering data about trees in on the streets. And really, this was meant to be a collection of every single tree in New York City, looking at qualities such as different, sort of the tree's health, looking at whether, and then, looking at the species of trees, excuse me, and looking at, for what I'm asking in some of the questions, whether trees have what are called stewards. So are there, people taking care of these trees, and how is that affecting their health? And Socrata itself, you'll see, like, this is through the city of New York. So if you go to the main site, like, that's where New York City's open data is. Socrata creates these open data profiles for many cities. So you'll see similar portals like this, but underlying all of it is the Socrata API language. And in particular, there's, which I'll get into in this notebook, is what's called SOQL, so the Socrata query language. So basically, first of all, looking at the data sheet here, we sort of get an idea of what's in this data set. So we have 45 variables and looks like around 684,000 trees. But if we begin looking at what we're begin sort of examining what we get with this API. So I included the API endpoint here, but you could just get that information from here, and then there are more API docs, although I'll go to what I link to in terms of SOQL. So if we first just try naively to just do an open pull, we have our API endpoint, and we're looking to just simply get all of the trees. We want to get a table. At first, this seems like we have what we want. So we have our 40 columns. We have, this is just looking at the head, so it looks like there's, quite a lot of information here. But as I mentioned down here, when we begin to truly examine the set and we examine the shape, we get, and here, I sort of mentioned 1,000 seems like too few trees, and we already know, looking at the site here, that we should be getting around 684,000. And the reason why this is happening is because these APIs are meant to be. They're useful for multiple multiple use cases. Like we're using them for more of a data science use case, but because it's such a large data set, just on the outset like this, it's optimized for being used in a web page. And if you think about what that means for data to be used in a web page, you're not going to take an extremely large data set and just bring the whole thing in. So as I sort of go through down here, Socrata has some API functions that let you offset and limit the data. So here you could see I'm setting my limit of 5 and setting an offset of 0. And in this example, you can kind of think if you have a mobile app and you only want to view a table, you want to view records or whatever you're looking at 5 at a time, you would essentially make the call for these 5 trees. You would have some sort of next button, some sort of way of jogging through the data, and you would essentially be operating through these functions here. So in this very simplistic use case, if you're just paging through results, you would be kind of just increasing your offset. So for the next 5, you would have your now offset being 5, and you would and so you would be sort of working with your data in that way. And the reason why I sort of wanted to have everyone use an API like this is because this really makes you think about what sorts of what you should be thinking of when you are developing an interactive visualization like this. So when you're working in RStudio or in a Jupyter Notebook, there's even for the largest data set that we were looking at, the Pluto data set, you're still able to bring everything in memory and kind of strong arm your way around the data. You're able to it'll take a while, but you're able to really work kind of perform any operation really you wish on the data. In a notebook or RStudio, there's you're if you're a data science professional working in these tools, you're used to kind of waiting. You have an idea of the size of the data that you're working with. You've thought about what you can and cannot do with the data, and so you're prepared if you need to just go grab a cup of coffee and wait for your operation to finish. For a web app, however, there's not for a web app, there's really less of a tolerance for something like that. If obviously there are some times where you need to kind of push a very long running operation off to the side and kind of give periodic updates in another way, but really transactions should be really minimized as much as possible. So using this example where we have we have 600,000 rows, if I were sitting there on an app and just clicking next, 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 I would be able to make, if I had the time, I would be able to make my way through all 600,000 records, and really kind of it's being optimized for what it is I'm doing. So I'm able to kind of comb through all of those 600,000 records without kind of in a stepwise manner, without having to bring in all 600,000 records at the same time. And so that's this is really very simple use cases where we're not doing any sort of operations on the data. All we're doing is simply viewing records. But for our use cases, what we want to do is perform, is get some sort of, summaries of our data. So, really the, you could think of this as kind of, the limitation I'm placing on you in terms of building this Dash app where, there's, rather than just simply bringing all of your data in memory and doing everything in Pandas, you need to think about sort of where you should be performing these operations. So, in this case, and then as I kind of go down here and explain more about the Socrata query language, you could see that you have SQL-like commands. So here I'm able to get all a count of each species of trees in the Bronx, and so this is something that um, it's involving all of the data, but it's sort of pushing the actual calculation of this onto the server. So, if you think about what exactly am I getting by querying this endpoint, I'm getting a table of 133 rows, and I'm getting these counts that were pre-calculated for me on the back end. And really, this is the core of how modern data-driven web apps work. So if and we kind of touched on this in our previous lecture where we were looking at this kind of server side versus client side dynamic. So basically, on your client side, that's just what's happening in the browser. Server side is really where the heavy firepower is. So the data in this case is 600,000 records. Still technically something that you'd be able to handle in memory, but really, if you're using any complex web app out there, you're doing this over insanely large data sets that it wouldn't be possible to bring in memory. So, on the server side, you're doing these very large calculations. On the client side, essentially all the client side is seeing is this table here. So from the client's perspective, it's seeing 133 rows, just looking at a single number for each tree. And that's, just really the way that, I kind of wanted to have everyone be thinking for this assignment. Another way that's more closely related to, to data science, especially as you move towards larger data sets, is the concept of moving the code to the data rather than sort of being able to strong arm the data. So, as I mentioned before, again, for even the Pluto data set, even if we did bring this raw trees data into the in memory, we would be able to put it in a pandas data frame, put it in an R data frame, and use dplyr or other group bys and do everything in memory. But but if you are dealing with truly large data, billions of rows, you would really want to offload that to someplace where you are able to perform larger operations. So in that case, even what you're doing as a data scientist working in Jupyter or working in R, you could think of in this way, where you're trying to and essentially you're parallelizing your workflow and sort of making sure that you're kind of once you do return to your environment, you have your aggregation and you're kind of working with that aggregated data. Although with moving the code to the data, you get way more complex about sort of which kinds of functions you could parallelize, which ones you can't, etc. And then just going into, this shows off a lot of the main functions that, you would need to use. So really, the assignment is, and let me actually get to the questions now. The assignment that the questions that we're looking at is we have a measure called health, and we could see whether trees are in good, fair, or poor health. And in particular, we're also sort of comparing this with the steward variable. So what we want to try to get an idea of is how is steward activity affecting the health of trees. So any questions on just the broad overview of the Socrata API and, really what I'm looking for, and what I was aiming to do by kind of adding this restriction?
So we can leverage the filter option here, right? The filtering of the data using a call, this web API, right? So if I add a filtering option, it's gonna limit the number of records it's gonna return in each call.
So if you filter, so you're right. If you filter using SOQL, you will limit the data that you're pulling.
Yeah.
But you would still need to sort of think about whether you're getting all of the data with a filter alone. So, for example, so a test I would run is, for silver maples, for example, we know that, sort of doing an aggregation, we know that we have 662 of those trees. So for that, we could filter and be assured that we would get the full result. However, for something like the little leaf linden, we wouldn't be able to do that. So it's only 3,000, so you can technically page through, just 4 times and get all of the data. But I would want you to think about whether, if you find yourself paging through the data, I want you to kind of, think about, is there another way to get the data in the shape that you want it, using the API and using the SQL-like commands in the API.
Okay.
Cool.
And that NAN records right on the top, how should we deal with that? Because one of the filter I end up in using is selecting the species so that user can go ahead and select the burrow and the species. But the moment you have NAN there, it screws up everything. I mean, the filter itself is not loading there.
Yeah, it does. The NANs will screw things up. It is fine just to drop them.
Okay.
Yeah. So.
Yeah, that's what I did. So.
Yep. Cool.
Professor, I have a question.
Mm-hmm.
This assignment, right? I think you mentioned that we have to. There has to be an option to select the tree species and the borrow. Okay,
Mm-hmm.
and then the visualization will show accordingly. Question 1, question 2 visualization, right? So when we select one particular borrow and a species, at that time, do we need to run the query, SQL query, accordingly based on what our input is, or should we pull everything first? But that will take a lot of time. I was trying to pull everything into a data frame by going through a loop until the end of, until my data frame is empty. But that was taking a lot of time, so I had to cancel that section.
So when you said you were worried that it would take a lot of time, are you thinking that it would take a lot of time to query, like as a user is making a selection?
Yes. So once a user selects the borrow and the species name, right? After that, if they run the query using that information, will that be better option?
So I would test that out before before deciding whether or not that's too slow. I would test that out because it's I don't want to give any more away, but yeah, I would test that out. Make sure that and email me if you test it out and it does still seem to be too slow, and I'll just double check to make sure things aren't being throttled. But I would rethink that.
Sure. Thank you.
Mm-hmm. Anything else? Cool. So with the last bit of time that we have here, I just wanted to get a quick overview of Dash-In. There is a video that I posted that was done by the Chief Product Officer of Plotly, just giving a pretty detailed overview of how Dash works. So I definitely encourage everyone to check that out. And I'll try to really focus on the on kind of the greatest hits here. So first of all, just taking a step back and thinking about how you guys should be running these Dash apps, testing these Dash apps. I had a few students email me about running them in Jupyter notebooks. It is possible. There's a I may have to Google it. Jupyter Lab. Jupyter Lab Dash. So there is a library that takes care of running Dash apps in Jupyter Lab. If you're comfortable using it, feel free to submit the assignment in that way. However, I would encourage you to try to run Dash apps just directly from the terminal. So basically, when like most people, most of you using Python, I imagine you're more familiar using Jupyter or perhaps something like Spider, which and then sort of even thinking about R, using R from an IDE. But all of these languages, like as you could actually see before I had RStudio working, I was trying to get myself prepared to use R from the terminal. All of these languages you are able to use from the terminal, and for developing Dash apps, I personally a lot of times I personally prefer just using a just using a text editor, something like Atom. That's what I'm using here, or using a text editor in conjunction with running things in your terminal. If you do choose this method and this is your first time sort of working in the terminal with Python, the one thing that I just want to highlight, that would give you the most problems would be making sure that your environment is set up properly. So so basically, as was mentioned before, when you're trying to deploy an app using something like Heroku, you're actually creating a sort of an environment on a blank Linux machine. But for running apps locally, you could just and I imagine with Jupyter, there's maybe a Python 2 and a Python 3 environment that you'll use, and you're just installing all of your packages there. That's totally fine to really sort of use that master environment to run your Dash apps. For Anaconda, it should automatically take care of your environments in terminal. So when you start your terminal, and by the way, just it's just terminal in your Mac. If you don't have it, I just always keep it here. And in Windows, it's CMD. So once you're in the terminal, you could sort of use CD to navigate, LS to list things. And once you get to your path where your app is, and actually I need to get back to, where was I? There I am. So, once you navigate to your path, you would have just a .py file. This is just something that's created from your just something that you typed into a text editor. And as long as your environment is set up properly, you'll be able to just run the app locally. So you'll see sort of a link provided right here. You could replace that 127.0.0.1 with localhost. And once you do that, you could just go to localhost : whichever port number is provided. So by default, it's just 8050. And then you're able to run your app. So that's just one thing to note about sort of the Dash app development lifecycle. Feel free to use Jupyter if you're, or Spider if you're really comfortable there. With Spider, you should still have end up with an app.py though. So with Spider, it'll end up being the same as if it's being used in a text editor. But one way to kind of think of Dash apps is to sort of just run it from the terminal. So once you do that, and then we are running out of time, but I just want to quickly talk about some concepts. So this tutorial, I'd recommend watch the video if you find that would be more useful, but going through this at your own leisure is also a very great way to kind of step your way through major Dash concepts. And I'm just going to focus on this Hello World app here, which really gives the sort of the bare bones, what a Dash app is. So if I go back here, whoops, and I actually wanted to use another one. I actually wanted to go here. So this is going to be a very simple Dash app. All it's doing is taking in something that I'm typing, and it's parroting it back down here. And so extremely simple. We're not even bringing in any visualizations yet, but this really helps highlight all of the major parts of a Dash app. So to quickly go through them, a lot of these map to what we had with Shiny. So you have your UI and server objects. With Dash, you have your layout. So that's almost a direct comparison to your Shiny UI. And then you have a collection of callbacks. And the way to think about callbacks are going back to sort of this conception of apps. When I was introducing Shiny, you could like callbacks are most of the time oriented around an output. So you would have an output. In this case, you have a graph, and you could see by the arrows you have two inputs to that graph. And so with this app architecture, you would have your two callbacks, and they would be referencing these three inputs. So in this app, it's very simple. All we have is a single output and a single input, single output. You could see the output here is just presented bare. So it's mostly meant to be used with one output. I say mostly because recently the support for multiple outputs have been added, but there are some caveats that you'll see in the documentation, so I won't get too much into that. For now, let's just consider one output. And you have you have the option for multiple inputs. So even though we only have one input, this is being presented in an array. And then what this is over here, this is called a decorator. And this is essentially defining, it's tying this function to your outputs and inputs. And so you could see that being done in the arguments here. So you have your component ID, my div for the output. That's corresponding to your div over here. You have your input, just my ID. That's corresponding to my ID over here. And then you simply have a function down here with as many arguments as inputs. So in this case, we have one. We just have one input value, and we're doing something very simple. We're just simply formatting a string based on whatever input is being typed in. Lastly, we have this function here, which is actually what's running the app. So this is the comparison to in RStudio, just clicking this Start App button. So, here that's being done at the bottom with the app down here. And that's pretty much a very brief overview. I wish I had a bit more time, but the video that I posted should be a pretty good intro for Dash. And in terms of the documentation here, this will delve into more and more complex situations. So things like more advanced callbacks, and then getting into cross filtering. So actually utilizing Plotly's interactivity as inputs into other functions. So I know that was brief, but any questions based on what I've gone through so far?
Yeah, a couple of questions. Just going back to that callback, can you assign multiple functions to the callback, or is it a single callback corresponds to a single function? And then secondly, once you're running your app in a browser, is there a way to stop it? What I've been doing, is just in the terminal killing the process, but is there a kind of a more graceful way to exit out of it?
So just killing the process in the terminal, that's the best way to end the app. And so there's no problem with that. And in terms of, what was your first question again? The, multiple functions. Yeah, so it is designed such that a callback is associated with just one function. So, the way to, and really the way to kind of think about this is you have our component IDs here. You also have component properties. So the, and this is what's guiding what your function is going to be doing. So it's taking in the value of, in this case, the text entry box as your input, and it's outputting, and children just means the, like if you have div, something like this. So I'm kind of doing this in, using raw HTML, but the, this whole element here is the children of this. similarly, if I added something like
Okay.
that.
And so if you had multiple outputs, you just have to define that within your single callback. Is that right?
Yeah, so in what way are you thinking of having multiple outputs?
Well, like say if you have two graphs, you know, one thought was to have, okay, have a single callback associated with two functions, but if it's only associated with one, then perhaps you can have two outputs associated with the callback.
So that functionality has been added recently. I believe, there it is. So yeah, this has been recently added here. Most of the time, it's just focusing on a single output, but here you could see, and the way to kind of think of this is this, and I'll move, or actually I won't just live code this, but the way to think of what this is doing, it's one callback, and this is something where you have one input that's controlling multiple outputs. So it kind of makes sense to look at it in this way.
Okay.
Before this was added, the way to do this would essentially be to have 5 separate callbacks. You would have your outputs and you would have your inputs. You could see you're returning a tuple here. So just a list of of results. I actually don't know if a list, it might have to be a tuple. But you're returning sort of multiple values, and they're still matching the children. They're still matching the format here. So if your multiple outputs had different formats, you would be sort of making sure that they match that. And then just to quickly show off as well, like when you do have an app that is using a graph, the output is now a figure, and you'll see that the function is just building a Plotly Plotly dictionary and returning that.
Right. Okay, great, thank you.
Yep, no worries. Actually, one more kind of point there, like when you're looking at something like this here. So this is kind of an interesting app because you have this control is being controlled by sort of this other control. So when I pick Canada, I'm looking at cities within Canada. If I look at America, I'm looking at cities within America. And so here, this is one way of sort of showing that, like, you want to be able to change the sort of change specific properties of your elements. So in this case, we have a drop down, and we're specifically outputting to the options because we're changing those to be either American or Canadian cities. And Chris goes through this in the video, and unfortunately, we don't have much time to go through that here, but email me if there are any other questions as you're working with this. All right, so I'll end this and then restart it for the second section, which is starting in 3 minutes. But good luck, everyone, on Module 4. And I'm looking forward to seeing everyone's final project proposals. So I'll see everyone later.
Thank you, Professor.
Thanks a lot.